This conference will now be recorded.
And then we'll go ahead and put it up for a vote. So our first co-chair nominee is Ryan Horseman. And Ryan Horseman currently works as a senior environmental scientist at ESA, and he serves as the board chair for Oyster River Ecology. Ryan has a passion for ecosystem restoration and has managed to weave many restoration projects into his more than 20 years of experience in environmental consulting in Florida and the Caribbean. And the Tampa Bay region is ground zero for his work and family adventures. So Ryan, if you're on the call, if you want to just wave, say hello. Okay. And then our second co-chair nomination is Allison Patronella, and she's been a research assistant with the Florida Fish and Wildlife Research Institute since 2017 in the Seagrass and Chemistry Lab, and she's the current lead for the Seagrass Restoration subsection. She'll also be talking about some of her current research on the agenda today. So I'm going to go ahead and put in a poll into chat. You guys can go ahead and vote. Anybody, is everybody able to get to that Mentimeter poll?
Work for me.
Okay, great. All right, and again, for those of you that have just joined in the meeting, we're voting on our new Habitat Restoration co-chair, Ryan Horseman or Allison Patronella. And
Gary, you might have to resubmit the link in the chat. Oh, there you go.
okay,
Marcus
I'll go
did.
submit that. Gonna go ahead and let that go. We've got about 31 folks that have voted. So we've got about 72 folks on the line. If you guys could go ahead and link in and put your vote in. Great. All right. I'm going to go ahead and leave that poll open for a little bit and let it catch up. And we can get started with the first presentation. So I'm going to hand it over to Jamie Swindaz, our co-chair that's been with us for a while, to start running the meeting.
Hi, everyone. Thanks for joining us today. Appreciate your attendance and participation. So our first presentation for today is Louis Sandoval from USF, and going to discuss seagrass aerial cover assessment in Tampa Bay using satellite imagery. Do you need us to, are you planning to share screen, or do you want Carrie to maintain power?
It's okay. You maintain yours.
Okay.
You want us to share? Okay.
No, you can use presentation. You can present.
I'm sorry, I'm having a hard time hearing you.
I'm saying that you can present for me. I'm
Okay.
talking. Yeah.
Sure. All right. Okay, there it goes. All right, I'll go ahead and put it on presenter mode.
Yeah.
Be shown.
Would it be easier if he tries screen sharing?
You're muted, Carrie.
Hold on, technical difficulties.
I'm gonna try sharing my screen. If that's better.
All right, I should have made you presenter. Sorry about that. See if you can share it now, Luis. All right, we can see your screen. All right, you're on the presenter view. Thank you.
Okay. Okay. Hello, everyone. Today I'm going to talk about some preliminary results from our project, which started last year, and the project is funded by Tampa Bay Estuary Program. Basically, the project is an extension of previous works on satellite sewerage mapping in the area. Okay, as context, this is the previous work we published about cigarette stench in the area for the period 1990 to 2021. We cover 4 regions. So we cover San Joseph Sound, Clearwater Harbor, Tampa Bay, and Sarasota Bay. And we use satellite images from Sentinel-2 and Landsat. So in that work, we were able to map seagrasses in 16 different years from the 1990-2021 period. We can see that data represented in the orange line. The blue lines here are data from the Southwest Florida Water Management District. And we compared those different data sets. We observed that the patterns of change over time were very similar among the different regions and also among the Tampa Bay segment. However, we had some gaps in the time series, basically because water stability was very, very patchy, and sometimes for some years it was not possible to map the whole area. So that's basically why we had those gaps. But for this project, basically the idea was to update the seagrass annual map and also try to fill the gaps in the time series. So this is possible by doing the mapping in smaller and separate areas and not doing it in the whole region at the same time. So this is basically this was the limitation for mapping seagrasses in very complex water. Other 2 objectives for this project were proposed. For example, the other 2 objectives were producing and detecting intra-annual seagrass changes between 2021 and 2023, and also derive water quality data from satellite images. The areas of interest were the 4 Tampa Bay segments, plus Boca Ciega Bay and Manatee River and Sarasota Bay. These 2 were treated as a single area because they are relatively small. So the seagrass mapping workflow that was used, it was the same that we used in our previous work. The workflow has 4 main steps, which include selecting good quality images for every year at a time. So, for example, if we filter Sentinel-2 images from 2020, we select the best images, like showing the best atmospheric and water quality for seagrass mapping. So once we select those images, we then go to the processing step, which is basically just applying some math, like on clouds and land. Then we just take those images and run a classification for every single image. And finally, we must take them together to create a single map from the respective years. And this is what we call the annual seagrass map. Basically, the whole workflow was implemented through Google Earth Engine, QGIS, and Python. Additionally, we implemented a Gaussian kernel in the map, which is basically smoother. We noted that this helped to reduce noise in the final map and avoid overestimations, as shown in the figure here. So you can see how after we apply the Gaussian kernel, the seagrass bed looks like, with less noise and looks better. So this was applied to new maps, also to the previous maps that were published in order to keep the consistency in the method and also measurements over time. So now for the intra-annual map, we selected some patches per segment, which are indicated here in the figure. I don't know if you can see, but there are some red lines that represent the location of seagrass transits from Tampa Bay Estuary Program that we hope that this information can provide some data or information about the potential dominant seagrass species in each patch. And in total, we work with 28 patches. So for the water quality data, we use daily modest aqua images from 2002 and 2023, which were processed to obtain monthly data, chlorophyll A, light attenuation at 490 nanometers or KD 490, and also the remote sensing reflectance at 667 nanometers or RRA 667. This is basically an indicator of suspended particles at the water surface. We were able to process 184 images in total to fill the gaps in the time series of seagrass extent. So the figure on the right shows the new data as green dots, while the white dots are the previously published data. There were some gaps that we could not fill because some images, there were some years that the quality of the images were not very good, especially in the 90s. And other common gaps are between 2012 and 2014. This is because there was a transition between Landsat 5 and Landsat 8, which caused like a gap here where there was no any image available in those years. And also, basically, well, here we can see that the trend shows constant increases in seagrass 10 in Boca Ciega, Lower Tampa Bay, and Middle Tampa Bay, while some recent declines were observed in Hillsborough Bay and Old Tampa Bay since 2015 and 2017. Now, this figure here is showing the seagrass extent variations in normalized units from March 2021 to December 2023 among the different patches of each Tampa Bay section. The color bars are representing the spring, summer, fall, and winter season. And here we can see the seagrass patches show some interannual variations, but there were not like expected patterns among the different seasons. It was not very clear that the seasonality here. But we observed visual changes in seagrass density for some patches, which can be seen here as changes in coloration inside the patch. Those variations were more visible than others. So, for example, the first 3 images at the top are from Old Tampa Bay. Here we can see there is like a change from low density in February 2022, then it goes to a higher density in May from the same year, and then goes again to low density in the next year and in February. We can see a similar pattern in this patch from Middle Tampa Bay, the 2 images in the middle. So it goes from low density to high density from January to May. And the last 3 images at the bottom are from a patch in lower Tampa Bay. In this case, the variation it was smaller, but we can see that there is some change in the density in this patch. And okay, so about the water quality data, there is not much to say. We're still in the process of analyzing the data, but in general, some differences between segments can be observed. For example, in the KD values, which are the plot with the purple dot, and the RRS 6 to 7, which are the plot with the red dot. So basically here we can see that the segments, some segments such as Middle Tampa Bay and Lower Tampa Bay present the lowest values over time. So basically saying or suggesting that the water quality was better in comparison to the other segments. Also, we can see that Hillsborough Bay, Old Tampa Bay, and Manatee River, those values were higher. For Boca Ciega, we can see that those values are like in between. So for chlorophyll, which is represented by the plot with the green dot, we can see that the chlorophyll is very variable among the different segments. There was no apparent pattern over time, but again, we need to complete the analysis to get a better conclusion about this. So what's next? We need to update the rate of change in seagrass extent. Also compare monthly water quality data with the intra-annual seagrass changes in 2021, 2023, and also compare the annual seagrass extent with the annual water quality data. And finally, we want to produce a similar water engine app that the one we published before, which is this one. So basically, in this app, it's free to use, so everyone can use it. The data is free. So basically, here the people can select different regions and different years and can compare how seagrass areas have changed over time, and also especially. Yeah, so this is just an idea on how we want to share and show the data to the folks. And I think that that's all I have. Thanks.
Thank you for that presentation. Does anybody have any questions? You can either turn your mic on or write it in the chat.
Hey, Jamie.
Hi.
Hey, this is Chris Anastasio with the Water Management District. Hey, I don't really have a question. I just had an interesting observation. First of all, that's really good work that those guys at USF are doing. We completely support the integration of satellite imagery. I think we've talked about in the past some of the challenges associated with satellite imagery. I think Lewis did a really good job of kind of showcasing some of the limitations, but one of the things that I just wanted to highlight that I think is really valuable in this is that increased in the temporal resolution. There was that one slide that he showed where you could see the change in a particular seagrass patch between January and May. And for our purposes, when we produce our biennial seagrass maps based on our fixed wing aerial imagery, that one right there, that's really, really good information for us because, as you all know, our flight window is pretty broad. And as I'll talk about later in my update, it was even more broad this year. But what this really does is it allows us to kind of gauge what the difference in coverage might look like over winter versus at the beginning of the growing season. So I think there's a lot of elements of this work that we find very valuable. Beyond just looking at it from a landscape scale product. I think there's a lot of really good information here. So anyway, I just wanted to point that out and let everybody know that that's one aspect of this research that I think is really helpful. Thanks.
Excellent. Thank you, Chris.
I had a question. This is Dave Tomasco.
Dave, go ahead.
So we know when the district does their maps that, we know the ground truthing that goes in, the post-map production classification accuracy assessment. So what is the post-map production accuracy assessment for this imagery? Is there any? And I'm not saying there needs to be for this, but, how do we calculate the accuracy of the maps that anyone draws is going out after the maps are drawn and making sure that it's seagrass. So is there a post-map production classification accuracy assessment for this product?
Yeah, that's a good question because we have, as I mentioned, that we classify like every single image. So we got some accuracy values for every single classification. But once we created the final annual map, there is another accuracy assessment at the end. I don't have the values, but we basically use the same data that the ground truth data that we use for one portion was for screening and the other portion was for validation. So we use the validation portion again in order to kind of validate the final product.
The guest was around ARAJ.
We
The person in that room was Trey, TREDIK.
I'm sorry, I was hearing someone in the background. So there is, with a water management district map, you can say it is 95% accurate. We went to 1,000 spots, 950 of them that we said there's seagrass. There was seagrass. There is something like that done here or not? I couldn't. Apologize. I couldn't answer. Someone else is getting the mic on.
What form are you? I remember you didn't tax.
Yeah, we have.
Excuse me, can everybody that's not speaking go ahead and mute?
Okay, I think we're good now. So I was saying that we use the ground truth data we have, and we use some portion of the data as validation. And we have those accuracy values. But yeah, that's basically the only metric we have here. But yeah, I don't know if that answered your question.
Okay, I think, Louis, if you could include, if you have an email address or preferred contact information, if you want to throw that into the chat box, so if anybody has any further questions or wants to reach out for discussion. I do want to remind everyone, I believe Kerry still has our voting open for Ryan Horseman or Allison Petronella as the second co-chair. So please check that out. The link is in the chat. We'll see if Kerry can throw it in there too. Our next presentation is going to be from Allison Petronella. Hopefully it doesn't bias your vote one way or another. She's from FWRI and will be presenting on reviving coastal ecosystems, a seed-based seagrass restoration. Allison, will it be okay if Kerry makes you presenter?
Yes, that'll be fine. Thank you.
Yeah,
Thank
I
you
went
very
ahead and already made you presenter, so you should be able to put it up there.
All right, can everyone see it okay?
Yes, thank you.
Excellent. Well, my name is Allison Patronella. I work with the Florida Fish and Wildlife Research Institute. I am the team lead for the seagrass restoration subsection. And today I wanted to share a little bit about reviving coastal ecosystems using new seed-based seagrass techniques. So a quick background on what is seed-based restoration.
Hey, Allison, sorry
Yes.
to interrupt you. We're seeing the edit version of it. We don't see
Wow. Okay. Cool, you can see all my notes. One second, let me retry that.
Allison, I believe if you go to the bottom right of your screen, there's like an option so you can hit presenter mode.
All right, how about now?
No.
Does not appear to have changed.
Okay. Sorry about this, y'all.
That's all right. It could be that you're just sharing the wrong monitor.
Does it look differently to you on your computer?
It says that I'm sharing the correct monitor, but you know what? I can just
Worst case, we can still see it.
Yeah.
yeah, I think we'll just do that. I'll just if I can share it like that. Is that all right with everyone?
Yep, just keep going forward.
Okay, it's not one sec. Okay. All right. So sorry again, but here we go. So seed-based restoration is, again, exactly what it sounds like. It is a seagrass restoration that is using the seeds or seedlings of the seagrass. And this is, instead of traditional donor material, you're not going out to a seagrass bed with a shovel and digging up some seagrass and planting it somewhere else. This is specifically using these seeds or the seedlings. And in our case, we are growing these seedlings out in a land-based nursery. Now, there's been some previous work on this by Moffler and Tomasco, or not Tomasco, sorry. Moffler and Duraco. I'm sorry, Dave, I just saw you. And they've done this previously with Thalassia testudinum. And this is great because Thalassia testudinum is very difficult to normally restore. And I've found that it's actually very useful to do in seed-based restoration techniques. So quick background, Thalassia testudinum can reproduce in two different ways, reproduce sexually and asexually. So asexually is vegetative. It'll grow new clonal shoots out of the rhizome, and asexually, the female plants will produce the fruit, which can contain 2 to 4 seedlings typically. And these seedlings are already fully germinated from the moment the fruit dehisces or opens up. These are ready to grow. Shoot, the wrong thing, sorry y'all. So with our seedling collection, we primarily focused on shore cast seedlings. These seedlings have been washed ashore. We are not taking them out of active seagrass beds. We'll find them onshore or nearshore environments, and this really gives them a second chance at viability. A lot of these seedlings have been dried out. They've been sitting in extremely hot, shallow water. A lot of them are not in very good condition. So the quality of your material can really vary depending. But what we found is we've got about a 50% survival rate once we collect them from shore, which is pretty good considering all of these seedlings would have probably died before our intervention. So as I said before, we locate a shoreline, usually using Google Earth, for a beach with a nearby seagrass bed. And this is all accessible by vehicle. You do not need a boat to collect this way. And we'll go digging through the rack piles and nearshore tidal racks. So in 2023, we actually collected from 6 different counties across the state of Florida. Big shout out to our friends in the Keys who helped us out. And we actually looked in 11 different counties, but we weren't successful in every place we looked. I think this is because there are many different variables that can impact the amount of seedlings that you find. So again, you need a good beach where the local tidal regime will actually bring the seedlings into you. And you also have to know when the fruits start dehissing in that area. It's a fairly short window, and when one of them pops, they tend to all pop at once. So it can be very lucrative. We've had times where 2 of us have sat down in a half hour and collected about 600 seedlings. And then we've also had times when you go out and you don't find any. So it's very important to get your timing correct when you are collecting these seedlings. In 2022, we collected around 3,000 seedlings, and in 2023, we collected around 1,400. And that, again, we collected less last year because some of the beds that were extremely productive in 22 just weren't producing in 23. So you really have to know where to go, but it can be very lucrative. So here's some pictures of what we find. If you look at the top right, you can see some seeds that are still inside the fruit. Excuse me. If you collect the fruits, you simply just let them sit in salt water until they open up naturally on their own. And then they look like, the picture at the bottom right, when they freshly come out of the fruit, they still have a little bit of that slightly positively buoyant coating. And the other pictures here, I like to call these a little bit crispy because, as you can see, some of the blades on these young shoots or young seedlings have red and brown on them. And that's because these seedlings we actually collected from the high tide line several hours after high tide. So these were extremely desiccated. They'd been out in the sun getting heat stressed for a very long period of time. We're able to collect them and rehydrate them in a bucket of salt water, and a lot of them recovered. So that's really excellent news. So once you collect these seedlings, you just put them in a bucket of local salt water and keep them out of the heat, and they are good to go. Which brings us to our greenhouse setup. So you can create a greenhouse out of almost anything. Ours is actually 2 chicken coops with a clear plastic tarp over the top. But that actually gives us a lot of flexibility because we can adjust just about anything to fit our specifications. We have 6 110-gallon holding tanks that are all individual tanks. They are not hooked up in a flow-through system. And this is really just one way that you can raise these seedlings. There are many different ways to do the same thing. So these are just some of the ways that we've found work for us. So as I said, these tanks are all individual setups. They are not connected to a flow-through system. And this is because I previously mentioned we were collecting across the state. So I needed isolation tanks, put up a sort of quarantine just in case any of our seedlings had parasites or viruses or any of the sort. So this system works very well for us. We use an undergravel filtration system, which is just a PVC stand with holes drilled in the side and an air pump to force the water flow through. So this is a very simple, easy to set up way to get good filtration. Well, once you got your filtration, you need your water. We've done two different things. We have collected seawater from the Skyway and stored it in large 55-gallon barrel drums. And that works wonderfully, except for sometimes a hurricane blows through and you need water really fast, and all the water in the bay looks horribly disgusting. So in that case, we've used Instant Ocean to make our own seawater. And again, both of these work perfectly fine. We've had great results with both. It's really just which works best for you. And because each of our tanks are individual systems, we only do water changes as needed on a tank-by-tank basis. We'll manually remove some algae, but we really haven't had many algae bloom problems. It's also important with your water, you really need to monitor salinity, because Thalassia seedlings can be really, really sensitive to high salinities. So we monitor ours daily and add fresh water as needed to maintain the salinity similar to the outplanting site. So these guys are already acclimated to the proper salinity for their new homes. So as some of you may have noticed, our greenhouse is in a parking lot where it gets very hot during the summer. So it's important to maintain our temperature, which we're actually able to do. We're able to keep the temperature between 20 and 30 degrees Celsius, which is great because that's ideal for our seedlings. And we do this by manipulating the greenhouse itself. We can add shade tarps to the roof to reduce the amount of sunlight going through. We can also add tarps to the side or take them off if we need to manipulate airflow. During the winter, during that one cold front we get a year, we can put in heaters and clear covers on top of the tanks. And our daily variation in temperature is actually fairly low. We can do about 3 or 4 degrees per day, which is pretty good. And finally, lighting setup. Now, lighting is not necessary. We have grown seedlings in these tanks without external lighting sources because we do have the clear tarp roof. However, we are trying to get these seedlings to grow as much as possible during the amount of time given. So in order to do that, we are adding a full spectrum 80-watt grow lights with a 12-hour light cycle. It's really funny, they're kind of pink, so if you come by after dark and they're still on, it has been called a flamingo bar before, so that's the nickname for our nursery. And this also shows that they will grow under these grow lights. So if your setup needs to be indoors for some reason, this will work. You can grow them inside using these grow lights. So our nursery is all set up and it's time to plant our seedlings. Although I think planting is a little bit of a misnomer because you really do not want to bury these fully under sediment. In my experience, you just kind of press them down slightly, indent them into the sand, and as they will grow these fine root hairs. And the root hairs will hold on to the sediment around them. So that'll keep them in place while they start to grow their true roots. We use beach sand that we collect from local beaches with a very small layer of peat and sand towards the bottom. We don't want to overdo nutrients because that might cause for an excess of sulfide and that will kill all of your seedlings. So we also add a little bit of crushed shell just because I like to add something for the roots to grab onto, just to increase, the below ground weight for when you eventually outplant. All of the seedlings we have currently, we are going to outplant next week. So I'll have a little bit more information for y'all after that happens. But let's check out the growth cycle of some of our seedlings. As you can see here, this is the seedling on the day of collection. It is about 2.5 centimeters. And about a month later, we've got much larger root and we've got several very nice sizable leaves. After another couple months, we've got even more roots. And again, the leaves have gotten longer. And this was taken last month. You can see there's multiple roots. We've got a nice short shoot and all of the leaves are looking beautiful. And this will vary on individuals. Some of the more stressed out seedlings that we got from temperature or desiccation might not be doing as well, but many of our seedlings were doing so well that I couldn't dig them up for photo day because their roots had really enmeshed with each other. So this is definitely on a case-by-case basis. So we've got all of these seedlings and we're planting them. We're trying to create an easy to replicate, an ideal planting unit for both the seagrass and for us as the restorers. We would like to create a planting unit that is really easy for us to store and to plant straight into the ground. And we also want the seagrass to grow really well in that unit. So because we have the seedlings to start with, we're able to manipulate how close they're growing together, how many are in a unit, and things like that. So currently we are working on that to find ideal planting densities and the easiest way for us to store and manipulate these planting units. So a couple of different things we've been trying. We've been trying out singular pots, which don't work very well for me. Larger pots, we've got trays. We've even grown them in Tupperware. Depending on what you have available, if you do it correctly, these seedlings will grow. Like I said previously, we're also trying to determine an optimal planting density to give these guys the best shot at life once they're ready for outplanting. So these are some of our 2022 crop. You can see on the picture on the left, we've got a really nice couple of rhizomes with clonal growth coming out of them. And in the center, you can see a really nice root matting. These seedlings were planted really closely together and it created a very dense root mat, which is really nice for planting because you put the whole root mat down, you just staple it and walk away. In the third picture, you can also see, again, very nice roots. These are clumped together, but they don't have the same matting structure. So it really depends on how you plant these guys and how you can encourage their roots to grow in a way that it works best for restoration. And all this below ground biomass is wonderful because it helps keep the plant planted in the ground. So next steps, as I've said previously, we are outplanting our current crop next week. So that's very exciting. We get to practice some of our outplanting techniques and play around with densities and see which of our techniques in the greenhouse work best in the field. And once we find all this information, we plan on writing up a best management practice. So look for that in the future. Next year, this year, we'd also like to do a genetic diversity study on our seedlings. So we will be just checking out the genetic diversity of our seedling crops and how that plays a role. And another thing we'd like to do is we'd like to look at how long we should keep these seedlings in the greenhouse for the best chance of survival. Currently, we keep them for around 8 months. Outplant them in the spring so that they're nice and settled by the growing season. But we're going to look into if you can outplant them sooner or later and which provides the best results for the plants. And with that, I would like to say thank you, and we can open it up to any questions.
Thank you very much, Allison. That's fascinating work. Does anyone have any questions, either in the messenger or just unmute yourself, please?
Hi, Allison. This is Julie Christian with the EPC of Hillsborough County. I was just curious, where are you guys actually doing your outplantings?
Oh, I forgot to mention that. So we are currently outplanting over at Wolf Branch, which is right next to Apollo Beach. We've got permits over there to do some to test out our new planting unit. So we'll be over there next week.
Allison, can you hear me?
Yes.
Hi, it's Mark Schramek. I work with NOAA National Marine Fisheries Service, Habitat Conservation Division. So, Allison, I heard you mention that you're not a fan of the individual planting units. Could you just elaborate why you don't like using those, say, as compared to a larger aggregation of plants?
You mean when I was talking about the singular pot versus like the large trays of units?
Yes.
So in my experience thus far is I've had a lot more mortality using the singular pots. And I've found with the trays, the seedlings seem to survive a little bit better when they have nearby companions. And they'll also grow themselves out to create a nice thick root mat. Whereas if you have a singular pot, you're going to need a staple for every single pot. But if you have a large, dense amount of trays, you're getting out more of these plants at a single time with less effort on your part.
Yeah, that makes sense. Thank you for explaining that. I'm captivated by this. This is this is a great effort. I'll be in touch. Thank you.
Thank you. Any comments? Sorry, go ahead.
That's okay. Yeah, I was just gonna point out we have 2 questions in the comments. Are you able to see them yourself, Allison?
Yes, I can. So the permits for outplantings, yes, we had to procure permits for that. I believe we have them through Hillsborough County. We have the EPA and one other that's not off the top of my head. And we typically collect our fruits and seedlings in the month of August. It really depends on the plants itself and in different locations. I know the Keys was popping a little bit earlier than we could get down there, and the Panhandle had a little bit later. It's very dependent on just local seagrass beds, so it really helps if you know someone in the area that can go out and look at the beach for you, and then you can just show up with your little red buckets and collect all you want.
Excellent. Allison, would you mind putting your contact information in the chat? I'm sure there's hundreds more questions. This was very interesting. Thank you very much for your time and your presentation today. I would like to keep us hopefully on schedule, and our next presenter is Stefan Hesterberg from the Gulf Shellfish Institute with his presentation for All Clams on Deck, Restoring Estuaries and Growing Coastal Economies. Stefan, is it okay if you go ahead and present? Carrie will give you power.
It's Stephen, I just made you presenter.
Okay, I'm working on it.
In the meantime, there was one more question in the chat for Allison. What months do you typically collect the fruit seedlings from shore?
I think she covered that.
Okay, she did. Okay.
Hey, Carrie, how do you, so I got a notification of like access. Is there a button on the go to meet for presentation?
Yeah, down at the bottom, there should be a screen button that you can click on to share your screen. So there's a mic, a camera, a screen, and then an X. So you see that?
Yeah, gotcha. Give me just a second. I have to allow access. Always something.
Yeah. I had my own tech difficulties at the beginning, so I get it.
While we're in a little bit of pause, can I ask, is there, on the last presentation, is there coordination with the Moat and UF study? I mean, they've got like $10 million over 5 years for doing seagrass transplanting technology nursery stuff. So is Moat, UF, and what, FWC, are they coordinated?
Yes, we do have plans in the future to work on a Moat-sponsored grant that a lot of the genetic diversity, I believe, will be working with several other people to go through with that. So we are coordinating with other groups.
Thanks.
Stephen, I do have your PDF, which I can try and share if you're having issues. You're on mute if you're trying to respond.
Did we lose him?
Don't know. Are you there, Stephen? Ah, there you are. Would you like me to share from here, or are you doing okay over there?
Stephen, if you could hear us, it sounds like it looks like maybe you're frozen.
Okay.
Should we go on to the next one?
Yeah, why don't we go ahead and go on to the next one? Tom, would you like to present on your end, or do you want me to bring it up on my end?
Let me try and put it up, be a presenter, but when you hit screen, it doesn't give you.
Yeah, I gotta make you presenter. Hold on a second.
All right, I got it.
Okay.
Can you see the underwater image?
Yes.
Yep.
Okay.
Thank you, Tom.
Sure, I just have to see how to make the thing move, but one sec.
So Stephen, when you get things figured out, just put it in the chat and we'll squeak.
All right, if you can see it in the picture, I'll go ahead and start. Now, a lot of you've heard this, so apologize for re-saying some of this stuff. For folks who don't know, we're working on some of the issues here with grasses, Tampa Bay, Chris Anastasio and all the other mappings that you have seen. We all know the story, right? Tampa Bay over the last 6 years has lost a lot of grass. In fact, Tampa Bay between 18 through 22 has lost over 10,000 acres of seagrass, okay? Sarasota Bay, same time frame, 2,800 acres. So this is not just a localized area, almost the whole West Coast. Charlotte Harbor even lost some. It's only in the upper part of St. Joe's Harbor where we didn't see any losses here in this last round. And that's concerning, right? What can we do about it? For Tampa Bay, a lot of the losses are in the upper parts of the bay, but all segments of the bay had some losses, even the lower Tampa Bay. And so all of us want to see these trends changing, right, to get this off track again. But this is not the whole story. On the east coast of Florida, Indian River Lagoon has lost way more grasses. In some places, completely no grass at all, no rhizomes that we know of, and hardly any seeds probably that are viable. And so for them to naturally come back on their own is going to take a lot of work. And so we are able to get funding because there's a lot of attention that's drawn to this, because these losses in seagrass have direct effects, obviously on fish and stuff, but for prismatic megafauna like manatees, that's a big deal, right? I mean, we had 2 times the amount of the 5-year average of mortality in 2011 and another 800 in 2022. Last year was actually good, even though over 500 died, but it's usually closer to 700 on average. And this year we're doing so pretty well in this first quarter here. But there are issues up in Hernando County. They had 5 mortalities in a month, and so there are concerns about seagrass and enough food for the manatees. So again, if there is no rhizomes or even seed sources, it'll take a long time to naturally get some of these areas that are barren of seagrass. And so there was state funding put aside by FDEP to plant 100 acres. Now, 100 acres is not when we're talking a lot when you're talking thousands of acres of seagrass loss. But this is not meant to fix these complete losses. This is not the way you get seagrass to grow. You need to fix the water quality issue if you really want seagrasses to stay. But again, if we have places where there's nothing, it becomes very important by planting 100 acres of grass. We have USF independently monitoring our work. And I asked earlier about permitting because it's a process. Even though the state is funding this, I have to get permits from the state and of course the feds and others to put grass in. And it's not easy. We've been working on this. I still do not have my first permit that we have applied for. We just got today the core permit for the Sarasota Bay project, but it's hanging on when I get the permit from the state. And I get a lot of kind of crazy questions in RAIs about, hey, we want to make sure you're not planting grass on top of grass. And I'm like, well, thanks for telling me that. But we really need this to be a little bit more streamlined. And so over 100 acres, we've planted over 30 And the only reason we could plant those are because we found locations and entities that already had permits but didn't have enough seagrass or capacity to plant them. As you'll see in here, we're planting primarily shoal grass, the haliduli, because it has the widest range of salinities and most tolerant to stressors. But in some places, we are also planting grass like thalassia, because that's the only thing that's in that area. And again, USF is doing a full-on study of our plantings to see how successful they are. They're only doing a subset. And so far, our sites have been holding up. For the ones that we put in 6 months ago are still growing and expanding. So that's a good sign. This map shows in these yellow dots where we've planted. Around the states, we've planted in 4 of the 5 water management districts. And you can see there's a lot. You zoom in on here, a lot were done around here because there are permits in place so we could go and plant while we're waiting. Like I said, we have a Sarasota permit pending. We're applying next week for Tampa Bay, and 2 weeks after that, we're hoping to be applying for Charlotte Harbor. We have locations. The hard part is to find locations because the RAIs and the information you have to provide to get permits, they want to know, all the mapping, what you've done, make sure it's the right place, all appropriate. But that takes a lot of time to get the good sites set up and then to get the permit. So it's an ongoing process. Right now, we're planting 6 acres up in St. Andrews Bay. Then we're going to have another 4 acres up in the Panhandle again at St. Joe's Bay. Then we're in Martin County. We have 10 acres going in there. So at the rate we're going, we're hoping to get close to the 100 by the end of this year. And so that's just an update of where we are. I'm glad to answer questions if there's time for that, or you can just contact me directly. We're just going to keep going. So my last plug is if anybody on this call has a location that has permits to install SAV, contact me because we may be able to provide the grass for you to do that. And that's it. Thank you.
Thank you, Tom. Would you put your contact email or information in the chat, please?
Sure will.
That way everybody can get a hold of you. Let's see. Stephen, are you available to try again?
Yes, I think we discussed, I was talking with Carrie about just someone else presenting or in presenter mode. My computer did not like trying to do that before. So.
All right, understand. Just a quick reminder, only 41 folks have voted for our co-chair. So Carrie can throw that link in if she gets a chance. And so please do that in the background. And Stephen, take it away. Thank you very much.
Sure. Thanks for having me. Sorry, I'm not going to have my video on. Again, connection and computer issues. Yeah, I'm excited to present here today. I'm going to be talking about the Gulf Shellfish Institute's All Claims on Deck initiative and where we're going with that restoration project. It was really Carrie's idea to have me here to present. She serves on our advisory panel, and I gave a similar presentation, much longer version of this, and she thought it would be a great idea to present our ideas for this and also a little bit of the site selection that we're doing to mainly get y'all's feedback. So I don't want this to be presenting at you. Really, I'm here to get good feedback from you. So thanks for listening. Next slide, please. All right, so what is All Claims on Deck? So the Gulf Shellfish Institute, we're a 501c3 nonprofit organization, and our mission is to increase the production of shellfish using aquaculture along the Gulf Coast, so support the industry, but also to produce shellfish for an environmental restoration. And All Claims on Deck came about after the 2021 Piney Point disaster, and our Vice President, Ed Childs, who lives on Anna Maria Island, is a local Floridian, You know, really that disaster was a wake-up call for him, and he really wanted to do something. And so his vision is to kind of merge shellfish aquaculture, that industry, with restoration, and use some of its features to improve water quality, recover lost seagrass, and then also have that in turn assist working waterfronts. Next slide, please. So Ed decided to, you know, spread this message far and wide. And as many of you know, there is a lot of money going into restoration across both from the state and the federal government. And Ed was successful at getting several appropriations for the Gulf Shellfish Institute to lead this initiative. So we have one federal appropriation, which is for 2.5 million, a state appropriation, and then a local county appropriation for another $500,000. And so all this together is our pot of money for this initiative for all claims on deck. Next slide, please. All right, so the budget, how will this money be spent? I like to include this slide because I think these are public dollars and we should be transparent as to what we're doing with them. The point I want to point out here is that the majority of this will be going towards scientific research and the monitoring of these restoration projects. Seagrass construction also costs a lot of money as well. All right, next slide, please. All right, so where is this vision going? So I kind of separate the vision from the goals. So Ed is not a scientist. And so my job and our job here at GSI is to take that vision and to distill it down into something that we can achieve. So I view All Claims on Deck is as a scientific collaboration to test whether native hard clams can help facilitate seagrass recovery and reduce nutrient pollution. And there's a reason why that that test is in big, bold, large font. It's because we are evaluating this, right? We have working hypotheses, and if those hypotheses don't turn out, then that's our finding, right? And co-restoration may not be the best approach. Next slide, please. All right, so we have a long list of objectives that we've created, and the one that I'm going to focus on here today is the recover seagrass habitat. So next slide. Yeah, that was supposed to be a quick transition. Next slide, thank you. All right, so so we want to evaluate whether the past evidence for facilitation by shellfish to seagrass can really occur at a management level scale. All right, so this slide is just kind of showing the broad idea as to the potential mutualism between the hard clam, which will be our study species, Mercenaria campechiensis, which is the southern hard clam, native hard clam, and then our seagrass, which we have selected to focus on Haliduli rhydi, and that should be of no surprise to all of you why we pick that. But the idea here is that, okay, can hard clams improve light availability, and then I think more realistically transfer nutrients through benthic pelagic coupling to assist in the recovery of seagrass at a little bit faster rate. In turn, though, I think there will be some benefits back to the hard clams that we plant. So there's been numerous studies that have suggested that you know, not only does the above and below ground structure provide refuge from predators, but also hard clams can grow faster in vegetated habitats. Next slide, please. All right, so what are the restoration approaches that we're taking? So we're going to take two approaches to our view of co-restoration. The first is exactly as you would think, direct co-planting of these two together. And we're going to evaluate that in, a multifactorial design with and without, each species. The other one, which I won't talk about today, but I do want to make you aware, is we want to see if basically the recovery of a hard clam population within a given water body can actually, that filtration power can actually move the needle on light availability and therefore expand seagrass beds. All right, so I'll just be talking about co-planting today. So next slide. All right, so where we're going to go with this is we're going to select 5 replicate co-planting sites all the way from Tampa Bay to Estero Bay. And we've kind of broken this up by important estuaries, national estuaries, as well as aquatic preserves. So we're going to have a site in Tampa Bay, which I'll be focusing on, but we will have Sarasota Bay, Lemon Bay, Charlotte Harbor, and Estero Bay. Go ahead and next slide, please. All right, so at the moment, it's a pretty straightforward experimental design. We're going to have 2 factors of seagrass, so seagrass present and absent, and then we will have 3 levels of hard clams. So no hard clams, a lower density of hard clams, and then a higher density to see if some level of recovery is density dependent. And we're probably going to go with circular plots. And we'll probably do this just because it'll speed up our plot construction. And we'll probably replicate each of these plots at minimum within a site by 8 replicates. Next slide, please. All right, so that's all well and good, but GSI has embarked on a pilot project in Sarasota Bay of doing co-restoration, that direct planting at a much smaller scale. And we have some interesting findings that have made us think about how to conduct co-restoration. So initially, we found is that there's been very high hard clam mortality at the site, and we're trying to parse out why that is. Is it abiotic, biotic factors driving that mortality? One thing we are noticing is that within our plots, these plots vary in their initial seagrass cover, so it's more of like a continuous design. The amount of seagrass that you have in the plot really dictates hard clam survivorship. So if you look at this figure here, you can see proportional seagrass occurrence on the x-axis and survivorship of hard clams on the y. First of all, the y-axis doesn't go above 50%, but really there's a shift around like 70% occurrence for seagrass where you start to have some better outcomes. So what we're starting to think of is, well, do you need to have a critical threshold to even make this facilitation aspect work? Next slide. We're thinking of a couple of modifications to this design. One is we're thinking about actually evaluating delays of hard clam releases. So maybe that the seagrass should go in first and get established, and then you add the hard clams. We're also thinking about could there be some sort of way to protect the hard clams long enough so that the seagrass can establish, such as, we've thought about using, in the aquaculture industry, cover nets are used, and they will use metal or chicken wire as an option, so that, unlike plastic, would deteriorate over time, which actually might be advantageous in this scenario. But we're thinking about modifying this design to evaluate getting these hard clams to live a little bit longer so that their effect can actually occur. Next slide, please. Next slide. I'll skip over this. Just to talk about our success criteria for this co-planting, you know, we have two aspects, right? So we're trying to do restoration on two species. So seagrass, we're going to use above 40% planting unit survival after 2 years. And for hard clams, we'll do 20% survival after 2 years. And to have successful co-restoration, we need to see a significant increase in the planting unit survival, seagrass cover, or biomass relative to that no clam control. Next slide, please. And for time's sake, next slide. All right, so I want to then, in the last couple minutes I have available, I want to talk about our current process and site selection in the Tampa Bay area. So this is something I'm interested in getting feedback on. So what we're doing as our site selection process is I'm first looking at the wonderful Swift Mud aerial maps that we have of seagrass cover going back to 2016 and comparing continuous seagrass change from 2016 to present, basically 2022. And so from those areas, we've identified that change analysis. We've identified some areas that look promising. The first one is Apollo Beach, and I don't have a slide for this because I was hoping that Allison might go over this site, but nonetheless, we're thinking about if there are some room there, potentially doing that site. I am a little bit worried about salinity at that site though. All right, so I'll talk about Bishop Harbor, Terracea, and a site near Anna Maria. Next slide, please. All right, so this is a Bishop Harbor location that popped up. Sorry if it's a little faint to hear, but I did try to pull, this is Google Map aerial imagery. I did try to, giving off Lewis's talk, I did try to pull March and the summer seasons. So you can see some change and loss from 2014 to 2021 here. This is kind of a little deeper depressional area. I've never been to this site before, so I'm curious if anybody has any ground truthing experience here, but this looked interesting. Next slide, please. There's a smaller area in Terracea that's shown some loss. That's been pretty consistent. It looks promising. Next slide, please. And there's a site in Anna Maria that's shown some loss, and I promise you that I've looked at these across multiple years. This is not just a seasonal trend that is some distinct loss that's consistent. All right, next slide. I think that should be it. Yeah, so thank you. My contact information is here. I'll put it in the chat as well. And I look forward to hearing your thoughts. Thanks.
Thank you very much, Stephen. We have about 5 minutes for any questions, if anybody wants to unmute themselves.
5 minutes for questions for all the talks?
Just for Stephen here.
Okay, thanks.
Any takers?
Hey, Stephen, this is Sheila with the estuary program. I just want you to know that we do have some data, some seagrass data on those like back bay areas, like Bishop Harbor and Terracea that we collected during Piney Point. I don't know if they align exactly to where your sites are, but maybe we can connect offline and I can at least give you what we have.
Thanks, Sheila. That would be wonderful. I appreciate that. And so there's also a comment in the chat from Dave. So yeah, this is something that has been like a consistent comment, and it's a fair one. But I think that from our perspective, the money's been allocated, and so it's fair to continue to remind the legislature and the federal government as in debate as to the use of public funds. But I think moving forward, I'm kind of over comments like this just because it is our initiative and this is going to happen, right? And so it's how can we best use the money that has been allocated now. So thank you for that. And but that's not something I think that is surprising or continues to help the feedback for this talk.
There's quite a few questions in the chat. Are you able to see them?
Yes, I do.
Okay.
So Nicholas, so no one has pulled any like grain size that I'm aware of right now. I think most of these sites from my experience have been they're pretty sandy. I am kind of curious about the Bishop Harbor one. And apparently Damon says there's lots of stingrays, so that's fun. Yeah, that's something we will be calculating though, and I'm kind of interested in across sites throughout Florida, right? We might have different sediment compositions and how that plays into restoration. How much clam mortality? Yeah, so that, Greg, that is something we're trying to piece out. So we're actually putting out at our co-restoration site in Sarasota Bay. We are monitoring hard clams using hard clam tethers. We obviously don't want to monitor the infauna by destructive sampling because that kind of negates the purpose of seagrass restoration. So we're using tethers, and we have put out some tethers that have cover nets over top of them. And the mortality is pretty consistent between the two. And we're gonna try to tease that out over the summer. So it could be more of an abiotic and site selection factor.
Chris Anastasio from SwiftMud has a question.
Yeah, hey, not a question so much, it's just something I wanted to add to what Sheila had mentioned. So this goes a long ways back when I used to work at DEP like 100 years ago, but I know we used to monitor Bishop Harbor regularly. I think it was like every month. And this was because of the one of the other piney points, not the most recent one, but the one that happened. I think it was like back in the mid or early 2000s. There's a lot of seagrass data that we collected over those years that we were doing that. I don't know where that is. I looked really quick on the page, the link that Marcus, you sent out. I don't think it's in there, but I know those data exist, and maybe they're in the Tampa DEP office, but there is a pretty significant historical data set anyway of seagrass in Bishop Harbor. And I did a lot of that field work, so I'm pretty familiar, at least 10 years ago, what it looked like in there. And there's a lot of areas that I think looked good, and potentially areas that could be augmented with some strategic planting. So just wanted to throw that out there.
Thanks, Chris. I'll definitely either follow up with you about that or see if I can find that data. Thank you.
Yeah, I may actually even have it. I'll look around in some of my old files and see, but yeah, definitely just hit me up and I'll try to hook you up with the right people to get that data.
All right, just for the sake of time, I think there's a couple more comments, even if you want to address them either through the chat directly, or folks feel free to follow up with him outside of this or within the chat. I do want to move on to our update section. So Tom already gave his update on his SAV restoration. We have Lauren Greenwald from the Southwest Florida Water Management District. She's with the ERP section, so that's permitting. She's talking about seagrass restoration permitting. Lauren, would you like Carrie to share, or do you want to take the reins? Do you have pictures?
I went ahead and made you presenter, Lauren.
I think you're muted. There you go.
Okay. Hi, everyone. I'm Lauren Greenwald from the Southwest Florida Water Management District, like Jamie said, and I work in the environmental resource permitting section. I'm an environmental supervisor, and I've been working in ERP permitting for about 17 years. I don't have a full presentation, but Jamie asked me if I would cover some permitting topics for seagrass restoration. So let me see how to share here. Okay, can everyone see my screen?
Yes.
Thanks. I'm sure a lot of you are aware, but there is a seagrass restoration general permit going through rulemaking with the Department of Environmental Protection. It's still in rulemaking. There's a workshop coming up this Friday or this Wednesday. Oh, sorry, no, this is out of date. That was last year. I think there is one coming up. Let me see if I can pull that up. But to go on, I wanted to just kind of quickly mention that whether the whatever happens with the general permit, this draft rule so far, if you can have your project meet the general permit criteria, that's wonderful. But I also think it's a really good framework for applications that would be submitted for seagrass restoration. So it kind of goes into planting and monitoring, what should be in monitoring plans, how often it should be monitored. All I think is great framework. We don't do a whole lot of seagrass restoration permits here, especially standalone seagrass restoration. A lot of the restoration we see is tied to a permit with impacts. But the biggest hurdle I've seen for getting through these applications is just demonstrating that the project is in fact restoration and it's not conversion of some other natural or native habitat to seagrass. That's all I have to talk about, and I'm happy to take any questions.
Thank you, Lauren. Would you be able to share the link to that information in the chat?
Yes, I can do that.
I do think, I know while you mentioned that the district doesn't usually do the pure seagrass restoration permitting, I think a lot of those bullet points, as you mentioned, are very helpful. So thank you. Carrie and I asked that for these next few updates, we save the questions to the end just because we've got a fully packed agenda for you today. So Lauren, maybe if you don't mind sticking around, or if you have any specific questions, feel free to send them directly to Lauren, either via her email address or through the chat. And Lauren, if you wouldn't mind throwing your email in the chat too, please. All right, thank you. Our next presenter is Chris Anastasio with the Southwest Florida Water Management District, talking about our seagrass mapping program, a quick 2024 update. And Carrie, Chris has, requested presenter mode. Thank you.
Yeah, thanks everybody. I'll be pretty quick. I just wanted to take this opportunity to update you guys on where we are with the 24 maps, but also just kind of wanted to mention a couple of other things. Just for those of you who are not familiar with the Southwest Florida Water Management District Seagrass Mapping Program, we map, basically our entire coast from just east of Cedar Key down to Charlotte Harbor. That's the map that you see on the screen. We do the Springs Coast, That's Anclo to Waxahachie Bay every 4 years, Clearwater Harbor, St. Joe Sound to Charlotte Harbor every 2 years. This year, 2024, is one of those years where we are doing the entire coastline. So it's a pretty big task. Within the Springs Coast region, we've kind of segmented each of these areas into sort of kind of focused around each of the river systems in the Springs Coast. Our maps go out about 25 miles offshore. So, we're basically working in the open Gulf of Mexico in many cases. And then in the south, the Sun Coast, we basically have our typical estuary segments, and then of course within those we have segmentations as well. But this year's been very challenging. As many of you know, we've been in an El Nino winter. We're starting to transition out of that, but we have completed our aerial acquisition. We had to extend our flight window. Normally our flight window ends at the end of February, but we actually went into March. And really, even into the first week of April, we had some areas, a few flight lines that we still had to do. So it's been very challenging, but we think that we're still on schedule to have the maps for the Sun Coast region released to the public by early 2024, so January, February timeframe, and then the Springs Coast maps will come out a little bit later in the year, hopefully around April, maybe May of next year. So we are on track. We are conducting our field work right now. We've completed most of our accuracy assessment data collection. And of course, those will be the points that will be used to assess the accuracy of the maps before we finalize the products and have them released to everybody. So we are making progress despite the challenges that we've had with the weather. And if there's any questions or anything like that as we move through the process from acquisition to photo interpretation and continuing with our field verification, please don't hesitate to hit me up and ask away. The other update I wanted to just give you guys a couple of other things really quick. I'm going to try to stop sharing this screen and share another screen. Let's see if I can get to it. What we have recently done, and by recent I mean like probably within the last year, is we've created a seagrass mapping tool. And I wanted to just share that with you all. I'll go ahead and put the link in the chat. It's available to anyone with the link. I do recommend that you use Google Chrome. It's a little clunky. This is really a beta version, but I wanted to give everyone the link to this tool because I think it's a very valuable tool. And we're just talking about some of the replanting areas that we folks are trying to look at. I think this is a good tool for that. There are some limitations with it. It only goes back to 1999, and it allows you to compare 2 years from 1999 to 2022 for the Sun Coast region only. So we haven't expanded this into the Springs Coast yet. But if you could see the tool, on the top left, you can actually select by base segment. So here I've selected Middle Tampa Bay. It's a little slow, so be patient. We're still kind of trying to work the kinks out, but what you see is what it does is it brings up the actual layers for those 2 years selected. Here I've selected 2020 on the left and 1999 on the right. And if you select a base segment, it will pull up the graph that you see on the bottom of the screen, which will give you the total, the acreage of continuous and the acreage of patchy. So it's a nice way to just kind of get a quick look at a particular estuarine segment along the Sun Coast. But the nice thing about the tool too is that it allows you to zoom in if you switch from segment to extent. And so I'm just going to zoom into Apollo Beach because we were just talking about Apollo Beach. And this is the comparison of the 1999 maps on the right and imagery, and then the 2020 maps on the left. And what's neat is it will do the calculations on the fly up in this upper middle section of the window. So it will actually calculate for you what the total is and then what the continuous versus patchy is, comparing 2020 to 99 or whatever 2 years that you want to compare. So you can see here, just as a quick look, this area that I have selected, this extent, we saw an increase of 1,099 acres of patchy seagrass between 2020 and 1999. So it's a pretty good tool. It does allow you to zoom in pretty close. I will caution folks though that once you get within about an acre, you're starting to get into the noise level of our maps. So be very careful if you're really zooming in too close to not take our maps too literal at those very fine scales. But again, you can see where it updated here. It's 769 acres, which is basically this extent. So I'm just showing you guys this. I will post the link on the chat. Feel free to use it. And if you do use our tool, also feel free to shoot me some emails and let me know what you think of it, because we're always taking feedback for this and trying to get, make it a better tool because it is kind of in a beta test mode right now. So definitely things that we know we need to improve on, but I think it'll give you guys a pretty quick and dirty way to look at our maps that go all the way back to 99 without having to download the shape files and bring them into ArcGIS. Anyway, that's my update. And that's it. So thank you. I appreciate it.
Thank you very much. And yes, please share that link in the chat along with your email address if you don't mind.
Yeah, will do.
We all love a good visual and a good comparison tool, so thank you. Our next update comes from Lauren Brisley from FWRI regarding Seagrass Integrated Mapping and Monitoring Program.
Hi, thank you. Can I go ahead and share?
Yes, please.
Okay. All right, how's this looking for everybody?
Looks good, thank you.
Okay. So my name is Lauren. I'm the new SIM coordinator. SIM is the Seagrass Integrated Mapping and Monitoring Program, housed under FWC over here at the Fish and Wildlife Research Institute. And I'm working with Becca Hatchell. She's the PI, and Brad Furman is the co-PI. So I'm just going to give just a little brief introduction, who we are, our contact info, that kind of thing. And I apologize if you've already heard this. We're just trying to make sure that we connect with all of the seagrass managers across the state. So previously, the SIM program was established in 2009 by Paul Carlson and Laura Yarborough. And they were working on a statewide program to assess the abundance and health of the seagrasses. And so they did that through the publication of technical reports, as well as estuary chapters. So we want to build on that. So we want to continue to connect with partners to aggregate, analyze, and summarize data from local, state, and federal programs as well. We want to write, publish, and present on our regional and statewide seagrass trends that we're starting to see. And we also want to identify data gaps. We want to find those areas in Florida that are lacking, and we want to lead proposal efforts to map and monitor in these locations. Additionally, we want to make sure we get our feet wet and conduct some site assessments and monitoring of past and future seagrass restoration projects. So when you've got new stuff coming down the pipeline, definitely let us know. And then, as Allison mentioned, we want to continue to contribute to the development of FWC guidelines for use of nursery stock in seagrass restoration. So we are excited to be able to support her initiative on that. And here's our contact information for both myself and for Becca, as well as the link to our website and a QR code if anybody wants to be able to pull it up really quick. And so these slides will be in with all the other presentations, so you can connect with us whenever it's convenient. We'd like to hear about new projects, old projects, funding opportunities. We're here for it all. Thank you.
Thank you very much. I know you had the fancy QR code and everything like that, but I guess just for consistency's sake, if you want to throw your email and contact info in the chat, thanks.
Sure thing.
Just a quick reminder, I think Carrie still has the vote open, so please go do that. Otherwise, our next presenter is Sheila from the Tampa Bay Estuary Program, presenting on Old Tampa Bay Seagrass Research Agenda. Sheila, take it away.
Thanks, Jamie. I don't really have a presentation lined up or anything like that. Really kind of wanted to just more have a conversation with you guys or bring it to your attention. So we're all pretty familiar of the recent declines of seagrasses in our region, particularly in Old Tampa Bay, which is now at an all-time historic low of seagrass acreage. And the causes for that seagrass loss aren't particularly straightforward. You know, much of the loss is Haliduli redii, which is a pretty hardy species. It's mostly in shallow areas, and over the past couple years, we've had pretty good water clarity. So currently, our team is working with some folks in the watershed to reassess the assimilative capacity within Old Tampa Bay and potentially use some of that information to potentially update or revise the management paradigm in that bay segment. And so kind of parallel to that project, we would like to convene a working group of some of our local seagrass experts and regional seagrass experts so that we can start co-developing a research plan or research agenda to try and understand and answer some of these questions about what's contributing to seagrass loss in Old Tampa Bay. We recently updated our seagrass or our research monitoring priorities as part of our CCNP interim update. And so we want to kind of work with our seagrass community to start answering some of those seagrass specific questions. So just wanted to really throw that out there. I'll be sending out an email to folks. If you're interested in participating and kind of joining this journey with us, please reach out to me or any of the TBEP staffers on the call. I don't know if Maya or Ed or Marcus, you guys have anything additionally you'd like to add?
Sheila, this is Ed. I think you covered the majority of what we're trying to gain from this new collaboration. In the past, when we've had struggles in certain areas, in particular with seagrass losses, we've convened sort of these smaller working groups to really focus and redirect our resources and efforts towards the primary research questions that are coming out as we've seen these losses in these particular areas. So again, Sheila is going to be spearheading this for us, but we're just trying to reinvigorate some of those past efforts and look at a little bit smaller scale on some of the particular research questions that we could incrementally address through additional resources and research effort from the community of practitioners that are on the call. So Sheila mentioned we're going to send out that request to y'all and please respond accordingly if you're interested in taking part in that journey, as Sheila mentioned.
Thanks, Ed. Thanks, Jamie.
You're on mute, Jamie.
Thank you. Technology's so hard. Thanks, Sheila. Next we have Carrie. She'll be presenting the habitat reporting for FY 2024 and the habitat report card. So take it away, Carrie.
So I just wanted to get online with you all and remind you that we do collect habitat restoration data from our partners every year. And this year we're doing a little bit differently. We talked about this at the meeting in December, but we've put together an online data entry form instead of sending out the Excel spreadsheets. So I'll go ahead and share what that looks like just so you guys know. It's the agenda. And here is our data entry system. So basically it has directions on the left, and then it has drop-down menus on the right where you can enter in your individual restoration projects, and it has information on, it has directions on what goes in each field. This is a, you enter each restoration project one at a time. So those organizations that have more than one restoration project, you may want to still go with an Excel sheet that you send to us. And so, you can talk to me about that specifically. And we're pretty excited about this because it's going to make it easier on us and hopefully easier on you. So that's coming online. It's actually available now. So if you want to start entering your restoration projects that happened or were completed between October of last year and you think will be completed by the end of September of 2024, you can go ahead and enter them now. And I'll be sending out a reminder email to partners that usually report on these, their habitat restoration projects. And then finally, I wanted to thank those of you on the consortium that gave us comments on the habitat report card that we presented in December at our meeting, and give you a link to the new and improved report card. So the link to this is in the agenda, so you can check it out. We cut down the text. We made it a little bit more easy on the eyes, user friendly. So check it out. Let us know what you think. The idea is we're going to take the restoration projects that you report each year, and those will be on the first page. And on the second page will be the habitat report card that we put together looking at land use changes. And so this will be a product that we'll be able to give to the community each year. You're welcome to give us some feedback as well for improvements for next year. And that's all I have. And I think that at this point we can go ahead and if anyone has questions on any of the updates, we can go ahead and do that now. So let's see, any questions for Tom, Lauren, Chris, Lauren Brisley, two Laurens, or Sheila about any of those topics, or questions for me on the habitat reporting?
Hey, Carrie, this is Brandon. Can you hear me?
Yeah.
I've got a question for Chris. I was wondering, I know the district uses fixed wing aircraft for their coastal surveys. I was wondering if there has been any discussions about incorporating UAVs or drone into that methodology. Having done a little bit of aerial acquisition for individual projects, just the component of trying to get the right tide, the right water clarity, the right wind can be very difficult on a just a project area scale, let alone a whole coastal system or bay. So just wondering if there's been any thought about that. And additionally, that may contribute to the how precise those aerials can be utilized. I know he talks about once you get down to about an acre, you kind of got to take it for what it is for the images. So just curious on that front.
Yeah, so that's a really good question. From a UAV standpoint, we are talking about that. In fact, it's funny that you asked that question because just yesterday we were talking about the possibility. We're not sure if we're going to do this yet, but we are looking at possibly launching some drones to look at some of the areas that we just haven't gotten great imagery because of the turbidity issues and the rain and the clouds and all those things that are have to line up for us to get really good imagery. And so we're looking into doing that. I think moving forward, our entire district seagrass mapping area is over 2,500 square miles. So a drone, unless you're talking about like the big, types of drones that, the DoD uses, it's not really practical for us to use that as a tool to in place of fixed wing. And again, with satellites as well, the issue is timing. Tasking a satellite to get an area and then, it clouds over, then what happens? You still have to pay for the time on the satellite. But I think where drones are going to be really important is to help us to do the field verification In those areas where the photo interpretation, we have some questions, it's a great tool, and I hope to be able to do that this year, is to launch some of those drones in some of the deeper areas that just got a bit obscured because of the turbidity or because of glint or waves, and use that to help augment what we do in the field in terms of our field verification. So yeah, definitely is something that's high on our list in terms of adding that as a tool to our toolbox. So yeah, any experience that you have to share, I'd love to hear more about it, because I know there's some other issues. We have done side-by-side tests before, and we've had mixed results, but technology is getting better, the platforms are getting better, so I think there's definitely a place for that in the very near future, if not already now. To answer your question about kind of the 1 acre, so we use 1 acre as kind of our benchmark minimum mapping unit, because, and those of you who are familiar with how water quality data are analyzed in chemistry labs, there's a detection limit for a parameter and a quantitative limit. Below the quantitative limit, that's where kind of your signal to noise ratio starts getting pretty low. Your detection limit is, below that, we don't know. So really the 1 acre, if you want to think of it that way, is more like the practical quantitative limit. It means that once you get below that 1 acre, it gets a little bit noisy. But in reality, and I'm not, saying this to, promote folks going down below 1 acre, but in reality, we do get much better detail than that, probably down to as low as 1/4 of an acre. And the reason for that is because our imagery quality has increased. For the Suncoast region, we're mapping with a 6-inch pixel resolution. So that's really, really good detail. Springs Coast, we're still at a 1-foot pixel resolution, but that's pretty fantastic. When you think about Modus Aqua at a 1 kilometer pixel resolution, you're getting really, really good detail. So yeah, 1 acre is a rule of thumb, but you could probably get away with a little bit smaller than that.
Yeah, I appreciate that. Yeah, in our experience, it's the use of the UAVs have been, it's certainly more of a smaller bite you're taking, but as I'm sure trying to get those optimal conditions, even though the fixed wing can cover so much more area, having those optimal conditions across that area is a chore, as I'm sure you know.
Oh yeah, it is a challenge for sure.
Hey guys, I'm gonna jump in. I really appreciate the conversation, but I know Carrie wanted to go ahead and announce the results of our co-chair. So if you guys want to get in touch with each other, please go ahead and exchange that information. And sorry to cut the dialogue. Carrie, you have our results?
I do.
We need a drum roll.
Go ahead and bring them up. Okay, you see the agenda? Okay, so the results of our poll, Allison is our new co-chair of the Habitat Restoration Consortium, and it was a very close race. And pay no attention to option number 3, get any votes. So I appreciate both of you for stepping up and volunteering to be co-chairs of the committee, and we definitely want to keep everyone that's involved in the habitat restoration field engaged in this consortium. So please continue to give us suggestions on where you want to see this consortium go. And just to kind of close out, we do want to get input on whether you're enjoying these themed meetings, and also, if you have any suggestions for future meetings, please reach out, or if you have suggestions for workshops or in-person kind of activities that we can get together and do. We're also looking for site recommendations for our in-person meeting in December. So if anyone would like to host the Habitat Restoration Consortium and has an idea of a site that maybe we can do the meeting and also do a field trip, please let us know. And if there are any other announcements or discussion, I'll leave the floor open.
I do want to remind everyone our next meeting is scheduled for August 21st. So thank you, Ryan.
I can see the election. Thank you, Ryan.
Appreciate the politeness.
Yeah, so the next meeting's August 21st. That's also a virtual meeting. And we do have a few presentations that we may have lined up for that one, having to do with land acquisition and wildlife corridor type themes. So let us know if you have any presentations that go along with that, or if you have a different idea.
All right. Well, unless anyone wants to chime in or speak up, y'all can have a couple minutes of your day back. Carrie and I really appreciate your time today. I think the discussions were incredibly interesting and valuable, and we look forward to seeing you all on August 21st. Please reach out to Carrie or I if you have any ideas, and welcome aboard, Allison.
We'll be in touch.
Thanks, everyone.